Okay, so in this lesson, we are going to talk about PLN, the planar number 5, and it is called minor and topological minor. So there are two similar concepts, and it is used for defining the planar graph and in many other algorithmic applications. 所以近期很多的研究都是专注在这上面，然后就是它能够把图的一些结构刻画的比较清楚一点点。那它会等下你会看到说它的概念在做什么。Okay, so we will start with a graph. Let's say X is a graph. Usually it is just a small graph. It is a structure, say K5 or K33. And recall the definition of Tx. Tx is a set of graphs. It contains a lot of graphs. It is obtained from X by replacing an edge with a path. So I did not write it very clearly, but I think I said it verbally, the full sentence verbally. So this means that all the graph that is obtained from X by replacing an edge with a path. You can replace several edge by several paths. 所以 Tx 这个东西呢，就是你从 X 出发，然后想办法把任何一条边换成一个长长的 path。你要换多长都没关系，不换也没关系。那这样会造成很多种不同的 Tx。Tx 里面有很多个集合。Okay, and we say G, if G contains a Tx, and this means that you have a subgraph that is an element in Tx. We'll show you an example later. Suppose this happens, then we say X is a topological minor of G. Okay, so this is a term to be where we are defining the small graph is minor of the bigger graph, and in this case, it is a topological minor. 当你的大的图里面删掉一些点一些边以后，你找到一个 Tx 里面的元素的时候，那我们就说哦 ，x 有藏在这个 G 里面，那 x 呢就是一个 topological minor. So we have seen the example before. Suppose X, let's say this is X. X is K33, and for some reason I'm using the square on one side and using the triangle on the other side. So this is one of the structure that we are looking for. And last time, we are looking for such a structure inside the Peterson graph. Okay, and if you recall correctly, or you want to do that again, the Peterson graph contains a Tx, a TK33. And how do you do that? You can say, okay, I want this vertex to be a triangle, and because this is a triangle, I want all its neighbors, its three neighbors, to be the square. And then you have to do some effort. But say suppose we found another two vertices to be the triangle. Then you will see that, okay, the triangle, each of the triangle has a path going to the three squares. And the same behavior applies to each of the triangle. Okay, it's getting messier, but I think you know what I meant because we did that last time. So when this case happens, we say G contains a Tx, and this language is the same as saying X is a topological minor of G. So really, this language is helping you to say, okay, G contains a certain structure. 就是当你发生这件事情的时候，就是说 G 里面呢有出现一个长得很像 K33的东西，它不见得真的就是 K33，但是你可以从 K33慢慢演化出来。那举凡所有 K33发生的一些性质，或者说 K33造成的一些不变，就是说它不是 planar graph， 那也会发生在 G 上面。Okay, so before I moving on to the next page, recall that we are replacing each edge with a path. And so now here is let's see, different idea. And as I mentioned before at the beginning of the class, okay, so now let's just look at the graph. Let's say X is the K5. Okay, so if you want to see the structure of K5, there are at least two ways. The first way is what we did before. You can consider Tx. And in this case, you are replacing edge by some path. This is reasonable, and all you are doing is just having a long path between two vertices. And so it preserves the structure. 它的结构是一样的。Now you see there is a different way to see, okay, this also looks like a K5. Instead of touching the edge, now we touch the vertices. So there is another concept. We call that as Ix, to be defined later. Okay, so in this case, each vertex is replaced by a connected component, connected subgraph. So 你会看到说，那同一个点呢就被换成是，比如说 P3啊，换成 K3啊，然后换成 C4啊，总之它是连通的，那它还是一块大陆嘛，就是你只是把一个点换成一块很大的东西，那它是必须要是连通的。And because now each vertex becomes a subgraph, it can be a huge subgraph. Then what about the edges? If you have one edge between the two vertices, then you have to add at least one edge between the two connected subgraphs. Okay, you have to at least add one edge. So let's say edge becomes at least one edge between subgraphs. 就是说你左边这个点变成一块大陆，右边这个点也变成一块大陆，那原本这两个点之间的一条边呢，就会变成说大陆和大陆中间的桥。那至于说你要建几座桥，那就是你家的事情。但是如果有连边，就至少要建一座桥。OK， 那等一下真的画一个图给大家看看。So this notion later on we have seen that it's called a topological. 就拓扑上长的是一样的。And the other I, the I means inflated. 填充进去的，就是变大的轮胎，你可以打气进去叫 inflate。OK。So there are two concepts of something that is similar to X. You have something similar to K5 on the left-hand side, but you also have something that really looks like K5 on the right-hand side, right? So either way is okay. Okay, so now we can say the similar things again. Let's formally define what is IX. Okay, now IX is a set of graphs. Again, it is obtained from X. Okay, and by the following replacement, like what I did before, each vertex can be replaced by the connected subgraph. And when you are doing so, the edges, you can duplicate some of the edges if you want, and at least one edge between the subgraphs. So a quick example, you can make your example easily. If X is equal to K3, then you can consider the set IX. And IX contains a lot of graphs, including X itself. Also, you can replace the top vertex with with a P2. Okay, so let me draw it like this. Right, you can use K1, you can use K2, or you can use whatever the connected subgraph. And now, at least you have to have an edge between all the three components. So you can do it like this, or like this. It's up to you. And you can see this is also in the IX. And if you wish, you can make something more complicated. Okay, so now we see that the two construction is fairly easy, and somehow it is similar, right? So let me show you an example to make the distinction. Okay. Another example, if X is equal to K14, and then you can replace the vertex on the top with a K4, with a P4. So this is one part. Okay, and then you have 4 vertices. You want to make the connection. You can do something like this. It depends on where you can draw it like this, but it's up to you. So anyway, you have to make an edge between the leaf and the subgraph on the top. And so by doing so, you can see that the structure on the right-hand side is somehow similar to the left-hand side, right?所以右边这个的结构跟左边是差不多的，只是这一次当我们说差不多的意思有一点点不一样。Okay, so Ix and Tx are really similar, but now if you look at this graph, and you may check. Do you think this graph contains an Tx? It turns out that you may check the following. Let's say this is G. Okay, G does not contain a Tx in this case. And the reason is fairly easy. On the left hand side, it is a tree and with a vertex of degree 4. And whenever you are replacing edges by the paths, this degree 4 vertex is always there. There's nothing changed about this degree 4 vertex. It is just a vertex, and then it is a longer path, and it is never like this, because on the right hand side you just cannot find any vertex of degree 4. So such a graph, it is an Ix, and it is never a Tx. 所以这里是顺便跟大家讲一个范例啦，就是说 Ix 和 Tx 就是都很像，对吧？那但是呢 ，Ix 呢是在跟你换点，没在换边的。但是呢 ，Tx 呢是换边不换点。那右边这个东西呢，我要讲说右边这个图呢，它是永远都不会是 Tx， 它不可能是 Tx， 尽管你 Tx 东西很多。原因是因为左边这个 x 呢，它有一个 degree 4的点。那你不断把边换成是 path 的同时呢，它只是一个，就是它现在是一个爪嘛，那它这个爪它只是那个爪伸的比较长而已，那它还是有一个 degree 是4的点，然后一路延伸下来。那所以所有的 tx 呢都长成是有一个中心点 degree 是4，然后有4条很长的 path 接出来。但是你如果看右边，它就完全不是这么一回事，它并没有任何一个点它的degree 是4。所以它本质上会有一点点不同。虽然说我们说结构上是相似，但是这两个相似的定义是有一点点概念上的不同。可以吗 ？Contain does not， 就是又 ，yeah， 没有，就是这个它没有 tx。就是这个它是它的 Ix， 但是 Ix 它虽然是 Ix， 但是实际上它就不是 Tx， 它不止不是 Tx， 它也包不住任何 Tx。我以为 X 是 G。可以吗？其他的。所以很像啊，看有没有什么问题。
但是有的时候它会不会是等价？就比如说我现在让这个 Ix 是有一个点是 degree 5，就是
没分上，
就像这个图一样，我这边是3，对，然后我这边
就成功了，
那
就成功了。Yeah, so sometimes yes, sometimes it works, right? Say if in that's why I draw it like this, right? Even you have a path of order 4, and somehow say I draw the graph like this. Yeah, and so in this case, I did previously I do one vertex to each of them, but now these two comes together. Whenever this happens, then you can use this as the center vertex. Right, so here is the center vertex, and then it will go all the way to here, all the way to here. Yeah, so in some cases, yes, you can still find it. 就是很多时候你其实找得到，那你要真的要找到说，是 IX 不是 TX， 也不是说那么好找。对，大部分时候 ，Yeah。但是你也会同时发现，之所以会没办法做这件事情啊，就是因为你这个点它的功能被分散掉了，原本要接4条边。然后你就把它分给4个点去做，然后就会出事。那所以呢，你如果把这个点原本就要接4条边的这个，还是有一个人能够接出4条边，那好像就没事，就比较没事。那所以当这个点啊，它 degree 不够大，比如说 degree 是只有2的时候，这个点旁边只有接2个点的时候，那不管你这里怎么弄，基本上应该还是会有找到一个点是 degree 2的，就是它不太会出事。Yeah, so that's a good observation. Then now we are going to talk about their relations. Okay, I put a question mark because there are still lots of things that we can think of. So first of all, the easiest one is the set of Tx is actually inside of the set of Ix for any x. And in other words, any g in Tx, if g is if G contains X as a topological minor, then sorry, let me say that again. If G is a graph in the Tx, okay, G can be obtained by replacing the edges. It is also a graph in Ix. 就是说，你如果有一张图是从把边换成是 path 换出来的，那你其实可以把它重新改写一下，然后让它变成是用换点的。基本上一个是换边，一个是换点。And let me show you a graph to make it clear. Say x is the K4, and let's say a TK4 looks like this. And these curly lines just says it is a path, a long path or whatever the length. 所以就是所有的 TX 都长成这个样子。And what we are going to do is try to replace that with some connected subgraphs. So you can imagine that, let me do 1, 2, 3, and 4. Okay, so let's see. Okay, so let's try to do this part. Put everything on the top for vertex 1. Alright, now for vertex 2, again we put everything for vertex 2 except for the remaining part. Okay, this is vertex 2. And vertex 3, you also take as much as possible. This is vertex 3. And then vertex 4, take the last part. Okay, so you see you have a component, and here is the edge. Let me use a different color. Here is an edge between 1 and 2, and here is an edge between 1 and 3. Here is an edge between 3 and 4, an edge. All the edges connecting to 4 are here, and 2 and 3, there is also an edge. So you have 4 components, 4 subgraphs, and they are connected by edges. So as long as you can draw that as a TX, and you can always find such a decomposition to make it look like IX. 所有可以写成 TX 的东西，它都可以写成 IX。那你要做的事情就是把第一个点想办法尽量连出去，把这整块都叫做它的 subgraph， 然后直到连到剩下的点之前呢，你就把那一块叫做它自己。然后呢，那一块建好以后，那你就去看第二个点。那第二个点呢，所有连得出去的就是都先连起来，都当做它的 component。那你就会把第二个区块也抓起来。那每个人都抓一些区块，那所以其实你刚刚连的那么长的 path， 只是帮你把你的陆地延伸出去而已。所以其中一个是比较强的，就是看你怎么讲说怎样比较强，然后 TX 是比较难达到的 ，IX 比较一般一点点 ，IX 比较一般一点。But as you observed before, in some cases, these two things are the same. This delta is the maximum degree. If this happens, then Tx is equal to Ix. And in other words, we have the inclusion from the other side. In this case, any graph in G, any graph in Ix is a graph in Tx. We also have the opposite direction. 在度数小于等于3的时候呢，这个 Ix 呢也会被 Tx 包住，所以它们会相等。在这个情况下才能够成功。So we know X is in our case the K4 has degree at most 3. So let's look at one of its Ix. The Ix looks like this. Ix has several components. Okay, and depends on what you want. Maybe you have a path here, you have a triangle here, you have a longer path here, you have a star here. Okay, and depends on how you want to connect them. There are different ways, and you can connect several edges also. This is an inflated X. But you see what happens here is, let me use this color. For this one, you only have 3 things. Okay, so let me draw it here. For each vertex, you have one inside. You have three things come in. right? They may or may not be the same vertex. In this case, it's 1, 2, and 3. Each subgraph has 3 things that come in. And because here is a connected component, connected subgraph, so there is a path going from the left to the right. There is also a path to connect this vertex to this path. So it is enough. It is enough to make this one as the vertex. Well, okay, I think I make a mistake. But anyway, you see, if the degree is not big enough, then you can choose this vertex as the vertex, and then you will have 4 vertices. 1, 2, 3. Here is good, right? Here is also good. It connects all the components. So in this case, you are able to, I'm not going to draw that, otherwise it is going to be messy. You have a path, a path, a path, a path, a path to connect all of them. So I think I make a mistake. Don't buy what I'm saying here. Let me make it more clear, and I will say that again later. If this happens, then G contains an IX if and only if G contains a TX. OK， 那我用中文再讲一下就是说，如果你的度数不够，度数不是那么大的话呢，那你可以画出一个 IX。那实际上这个 IX 它还是不会是 TX 啦，因为 TX 其实结构长得很简单 ，TX 一定要长得像上面那个样子，它就是 path 被换成边被换成 path 这样子。所以下面这张图绝对不是边被换成 path 的样子，因为它多了好多有的没的东西。但是呢，下面这张图呢包了一个 TX， 下面这张图包了一个 TX。那原因就是说，因为你的度数也不是那么大，你的度数就是只有3而已，所以呢，你把每个 subgraph 连通的 subgraph 抓出来的时候呢，它就只有3个接出去的点。你有一块领土，这块领土呢有3个入口。那这3个入口呢，因为它是连通图，所以你一定是有一个接点，有一个道路先把左边和右边先接起来。然后呢，你下面这个出口呢，一定有一个道路可以接到刚刚那条道路，这样大家才会连在一起。那当这3个东西接在一起的时候呢，它就会有一个点，它的 degree 是3，你就可以用这个点当做是当初这个 TX 要做的原本的那个点。那接下来你就用一些道路，一些 path， 就把这些点把它全部接在一起，这样子。OK。那所以我一开始写错了，上面第一点写的是对的，就是 TX 呢绝对是在 IX 里面，任何一个是 TX 就是一个 IX。那但是呢，IX 很长时候不会是 TX。那但是呢，当度数不够大、不够小的时候呢，这个任何一个 IX 呢就一定也会包含一个 TX。所以你抓了一个 TX， 你就会看到 IX。那你抓了一个 IX， 它里面就会有 TX， 只是它不见得会一样。Let's stop here.